Hello everyone and welcome to my presentation, Construction of a Portable Gas Measurement System for an Unmanned Aerial Quadcopter. I'm Ahmed Fakhani, a Mekatronik student in my fourth year, and my supervisor are Professor Dr. Tuba Çonka Yıldız from the Türk-Alman Üniversitesi. Each day, the air quality monitoring is getting more important issue in the recent years due to climate change and air pollution. And when we have a look over the carbon dioxide over the last year, we can see that it has been increased. There are many reasons for measuring carbon dioxide, like CO2 can decrease productivity and affect the energy efficiency. High level can lead to lethargy and fatigue. For that, the idea come to use a drone, since the drone is growing up in the market size, being used in the different branches. It also faster, cheaper, can move in more direction than the other technology innovations. It can also work with human being away from the place that needed to be monitored, which means safer for us. The designing of the system includes 3 sensors and a microcontroller, a GPS sensor, a gas sensor, and a GSM module to send the data to the database. For the user interface, a database will communicate with the website to display the data. The components of the system are Arduino Mega. The reason for choosing the Mega is that the Mega have more than one UART protocol. A new 6M GPS sensor that has a maximum navigation update rate of 5 Hz, a CC S811 digital gas sensor can detect carbon dioxide from 400 ppm to 8,000 ppm. A SIM800L GSM module, which works with 2G networks. After buying the sensor, the first thing to do is to solder the pins to be able to connect them to the Arduino. The GPS and the GSM communicate with the UART protocol, and the gas sensors communicate with the I2C protocol. The process of the software is described so. First, to establish a connection between the internet and the GSM module, then to take the data from the sensors, on top of that to send the data to the database, and last to display them. The knowledge that was needed to run this project is Arduino programming, database management, back and front web development. The programming of Arduino for the GPS sensor was done with the Tiny GPS library. The GPS sends continuously an MS sentence that was decoded with this library. For programming the gas sensor, the SparkFun library were used. Since the GSM module is an AT command-based device, the programming was done with the help of AT command by opening the GPRS connection, setting the APN, establishing the HTTP connection, calling the URL, and last to define the method of transmission. For creation the database, the XAMPP was used, and a table were created with the needed parameter. In addition, with the back-end development, the creation of the connection of the database and the website for accessing the parameter was done with the PHP language. With front-end web development, a graphical user interface was designed that has a section showing the position on a Google map by using the iframe, a live data for carbon dioxide and the time. In addition, another section was created for the table to display all the data, and the table could be exported and saved. The tests that was done to measure the performance of the system was indoor and outdoor tests for the GPS and the GSM for the signal strength. The indoor test was as much as good as the outdoor tests, as seen in the figures. Another test was carried out is the transfer rate. A different rate was tried to send the data with, and every 4 seconds was the best rate that could work with. As a conclusion, a research was done for this project, and the outcome was a light, low-cost system that can detect carbon dioxide and position, send it every 4 seconds to the website, and to display it. This project is just a start for the air quality monitoring by drones. In the future, other dangerous gas could be monitored and could be done with an autonomous drone without any human intervention. This is references, and thank you all for your attentions.